All right, rooted trees. So jumping into this, we got some definitions. I would highly recommend like taking the time to write these down. They're kind of going to be key to kind of make sure that you're understanding the vocabulary. I've got this set up so that we got several examples to look at. So here we go. So rooted tree. A rooted tree is a directed graph, a digraph, formed from a tree by designating specific vertices, a specific vertex, as the root. So the key thing is this root. It's kind of like the initial vertex you're going to start from, and directing each edge away from the root. So the root is your beginning, and it directs away from there. According to Theorem 5, there's a unique path from the root to the vertex and other vertices. So given the edges u and v, the direction starts at U and goes to V, right here. If U lies in the same path from the root vertex V, otherwise direct the edges UV, right? So now the definitions. A parent. So if V is a vertex in a rooted tree, other than the root, the parent of V is the unique vertex U such that it is directed edge from U to V. So essentially what this is saying is that like your sorry, let me pause for a second. All right, if V is a vertex, basically what this is saying is that U is where you started, so it's the parent, and you start at U and you go to V. In contrast to that would be a child. So when U is the parent, then V is said to be the child. So imagine you have a segment that you're starting at U and you're going to V, and so when you do that, U is the parent and V is the child. So like if I just had like a line segment here and this was U, and then I was going down to V, so U would be the parent and V would be the child. Then we have siblings. So siblings is that if we have, if V and W are parents, then we say that V and W, if V and W have the same parent, so like for example, let's say I had a vertex like this and coming off, and this was V and this is W, then this is the parent, this is the parent, and these are the siblings. So essentially what's happening here is that we're using, we use these analogies of parents because with rooted trees, we're often talking about family trees. And so we're just kind of like using this same vocabulary to decide rooted trees. Then we have ancestors. So in an ancestor or a descendant, what we have is we have in a situation where it's a little more intricate, but these are the people that are off the parents. So, and we'll take a look at an example of this in just a moment. And then a subtree is just nothing more than just a part of the tree, the rooted tree, that is being identified. All right, so here's our example. Let's take a look at this. Clear the screen. Okay, so here's one of the examples, I should say, not the example. So find the rooted tree that is formed from the tree in figure 4a. And so essentially what we're saying here is that vertex U is chosen as the root. And so if we see that, then we know that in this particular case, so if we start at U, then we're looking for a rooted tree that is a directed graph that starts at U and goes towards the other vertices. So when we look at this, we can see here that this graph right here starts at U and directs out away from U. It's directional, so it only goes out. It does not go in. And we look at this guy, it also goes out. It goes out to S, to T, and to V. This one goes out to S, to T, to U. All right, and then if X is chosen as the root or the starting point, then we can see that right here, we start at X, we go out to Y, we start off, we go to Z, we start off, we go to V. So that would be the rooted graph or rooted tree based upon these examples. All right. So now looking at, this is like a specific example for you to kind of use the vocabulary and apply it and like see whether or not it's making sense. So in figure 5a and 5b, what we're trying to do is identify different parts. So in the first one, identify the root of the tree. So in this particular case, the root would be where we start. And so since this guy starts up here and points down, leaves there, then that means that our P is going to be our root. The second is going to be our parent of vertex U. So we go to vertex U, that's it right there. And we say to ourselves, let's just do this. So the parent of your vertex U is going to be Q, because that's the only way that you can get to U. So Q gave us U. The children of the so we're looking for the children of this. So we're it says the children of vertex S and the vertices W and V. So let's just put some lines or some dots on those. So vertex S, and sorry about that. Yeah, so vertex S, and it says identify the children of vertex S. So we take a look at that, and it says that the children of vertex S are the vertices W and X. And so what they're saying is, going off of here, there's only one way to go. So we get W and we get X. All right, siblings. So siblings are going to be like, we consider them like brothers, right, and sisters. And so for letter D, it says the siblings are, the siblings of U. So let's change colors. So let's go to U. And it says that the ancestors, my bad, let's see, letter D. The sibling of vertex U is T. And so when we look at this, we see that vertex U is right here. And so we go up and say, okay, so Q gave us U. So the sibling of U would be T, because T and U both came from Q. All right, next one is ancestors of vertex T. So ancestors of vertex T. So let's go find vertex T. So vertex T is right here. And it says ancestors. Well, ancestors are going to be not parents, but like kind of like descendants of that, or sorry, ancestors. I'm saying the wrong thing. I was looking at descendants. So the ancestors of vertex T are going to be the vertices Q and P. So Q and P, because as we move back through the directed graph, those are our first vertices we came to. Those were the hierarchy of what we're looking at. Letter F is the descendants. And so for letter F, it says Q is the descendants. So let's come over here to this one. So letter Q is the descendants. It says that the descendants of vertex Q, the descendants of vertex Q are vertices T, U, Y, Z. So T, U, Y, Z. Those are the descendants. So Q is going to deliver us those 4 vertices. And then last but not least, it says draw the subtree of the tree in figures 5A and 5B that is a root, excuse me. All right, so we start off and we look through here and try to find a situation. So the tricky part about, well, I guess, so the one they're claiming is going to be this guy right here, and it is a root because of the fact that it has 2 things off of it. So those are our children. We could go up a little bit higher and we could say that Q is the parent of those 2 guys. We could go a little bit higher. We could say that P is of P and S. All right, that kind of takes care of that area. So then we could say, the tricky part with this, though, is that we have to make questions. Sorry about that. Right. But I think that gets it. So those are the 2 different subtrees of there that we could look at. Oh, I'm sorry. Here's another subtree over here. So S could be another subtree like that. All right. So the different subtrees. That's everything for the notes for this section. Yep, that's everything. So that gets us through trees and rooted trees.